A few days back, I was talking to one of my friends, and so he is into a different domain than analytics, and he was asking me, why do people trust the results from data science projects? Why is there so much of hype and like why do businesses kind of go against their gut feeling or spend so much amount of money in trusting data science practitioners in the models that they build? So this is a very interesting question that many people who are probably not from this field would try to understand in some way in very layman terms. So what we decided is we've come up with this video where we try to dissect this concept of data science models and what kind of things does go in data science or analytics projects, and essentially why do people trust them in a bit, right? So data science projects, as some of you might already know, this is a scientific process or a scientific way of research to solve different business challenges, right? And one of the things that differentiates scientific inquiry from physical research or physical examination is that a scientific inquiry often, especially in the field of data science, uh, is done through controlled experiments where there's no physical examination of monitoring physical objects in real-time space, but most of it goes as you have a hypothetical space set up out there, which is often called a data space, where you have different data about different variables that you want to measure, and you try to study them in a certain controlled way, right? For example, there are concepts like store testing, where often what businesses do is before launching a product on a wide scale across different stores across the globe, what they do is they try to understand the sentiments of their customers within a small store or a set of stores rather, and they try to understand if the product is going to be a success across similar other stores in different geographies. So this kind of a study is often what is labeled as store testing, and there are different variants of it. We'll not go into all of the details, but this kind of gives you an idea of what kind of projects generally happens in this field, and why they are interesting, and why people invest more money and their efforts in building this kind of statistical models, right? Often there are clinical trials or clinical studies where instead of, so for example, a new drug has been discovered by scientists, and before even implementing that drug or before even approving the drug, what is done generally is some trial studies are conducted where this drug is provided to a sample set of individuals, and if they kind of work on those individuals and they kind of significantly improve their overall health, let's say, then this particular drug is introduced to larger and made accessible to larger sections of the society. One of the most important aspects of any data science project is the assumptions that goes into the different statistical models that people build. Right? So it's very important to make these assumptions, realistic so that they fit the real world scenario, and then any kind of relevant statistical or mathematical technique, a combination of these techniques are used with different tools and technologies and algorithms. So everything is combined along with a business knowledge, a domain knowledge. You need to have a sense of that. And once everything fits together, then what comes out of this entire project is, a consulting idea, right? One crucial aspect of any analytical project is in studying the relationships among the different variables. The entire reason for data science projects or so much hype after the data science models or statistical models is because the gut feeling of businesses are combined with a process of scientific inquiry, And this scientific inquiry is made or enabled through data, right? Once we have data, we get the insights from this data, and it also, probably not always, but if it aligns with the gut feeling of businesses, this leads to better decisions, and these decisions are more informed. The main problem with gut feeling is that you do not have a scientific evidence to back your feeling. For example, if you're a firm and you are spending a lot of amount in advertising of your favorite brand or a favorite product, and you are spending a lot of dollars for advertising that, in your mind you would always have the notion of return on investment. So you're spending on different media, for example, through television advertisement or through radio announcements, through magazines, through circulars, newspapers, and many of the different media. And the overall idea for you to have is to have a healthy return on investment. Now, you could, as a business, often have this gut feeling that if I increase my spend on television advertisement, this is going to lead to an improved sales of this particular product. Right? But often the relationship among the variables are very complex, and unless we have data for such variables, it's not a wise thing to just go by your gut feeling and invest a hefty amount of money on your gut feeling. For example, there could be different sorts of interactions between different marketing tactics, which is often termed as the marketing mix. For example, if you increase a dollar worth of investment in television advertisement, the efficiency or the effectiveness of your advertisement through television might not be the same if you spend maybe half a dollar on television and half a dollar through radio, right? There are often concepts which involve learn and decay, which entails the notion of how long is the advertisement's effect going to stay in the mind of the consumers. So if you see, often you might have come across different advertisements where you see a particular ad on television and you retain that for maybe 2 days, maybe 3 days, and that kind of stays in your mind for quite some time. And you might go and purchase that product that is being displayed on the ad after a few days. So often, advertisement does not lead to uh, instantaneous results, but it might have a result which is a little delayed, right? So there are such things also that goes on, and these kind of patterns and knowledge is found once we have proper data, the relevant data around the variables, different factors. Then the statistical model that is being developed, that makes much more sense. For example, there's also competition in the market, and there might be competitor brands whose data, if you have accessible with you in some form, that gives a lot of insights into the entire statistical modeling process. And there's also a lot of interplay that goes on in the form of store dynamics. Some stores are small, some stores are bigger. There are different store formats. Something is like a neighborhood store kind of a format, or something might be a super center kind of format. And there are many dynamics in reality which kind of goes on behind the scenes, and it's very important to capture the right data at the right granularity and the right time frame to be able to come up with an insight and a decision which definitely is of a lot of value to different businesses, right? Now think of this situation where you have the spent data for five individuals, right? And that is 100, 200, 300, uh, 400, and 500. Now somebody comes and asks you what is the average spend of these people. So what you would do is you would sum up all of these, right? So 500 plus 400, 900, 1000 and 1500 by 5, right? So 1500 by 5, which is 300 is your average spend. Now, if somebody comes to you and asks that, so there's this new person say X, and you want to understand what is the average spend that he would incur, you would say that on an average this person would spend 300. But let's suppose you have this different situation now where you also have the data about income and spend, right? And let us plot this in this way. So say you have spend here and income on this side. Maybe the other way around for clarity. So here you have income, here you have spend, right? And let's say this is your 100 spend, this is 200, 300, 400, and 500 worth of spend. And you now also have the income of different individuals out here, right? Let's say this person has a uh, it starts from $600, 700, 800, 900, and around $1,000. Okay. Now, what we are trying to say here is, if you know the income of a person or of an individual, will it be easier for you to predict the average spend of any individual who falls within that income range? For example, this person X, he has an income range between 800 and 900. What would be his spend? So obviously, if we tried to understand, the average spend of individuals in this way, we would get a straight line from the above example of only the spend data, where we said that the average spend was somewhere around 300. But now, so knowing only the spend information did not allow us to understand what income group the person or individual belongs to and take that into consideration while being able to predict his spend. Now, if we know his income level or a range, we can approximately say that any individual who has an income level between 800 and 900 is expected to have a income or expected to have a spend somewhere around 400 instead of 300. So this is the benefit that we get from this extra source of information on income. So essentially, what we are trying to say here is that average of a single variable, let's say y, is not as good as expected value of the same variable y given data on other variables, which we can you know call under x. So imagine x to be like a entire set of different x's or variables, and we know the information of all such variables, and this helps in understanding what should be the average value of y. Now, when we talk about data science or analytics, statistical models definitely comes into the picture. Uh, Now, let's try to understand from the very basics what exactly is a model. A model can be as simple as an English statement as well, or a sentence. You could describe a certain relationship among variables or just two variables through a model. In its very simple form, a verbal model is one where you construct a sentence or a phrase, a couple of sentences to describe a real world situation. For example, if you wanted to build this relationship between income and expenditure, you could say that something like people generally tend to increase their spend or expenditure with an increase in their salaries or with an increase in their income, all right, keeping everything else constant. That's a very simple model. So what uh, idea comes out of this particular verbal model is that if somebody is given some extra cash or somebody's income increases, that person is rationally expected to spend a little more than usual, in a normal situation. What follows is a graphical model, which is again an extension of this verbal model, but here you do not really, stick to the sentence or the phrase form, but you describe this relationship among variables through some diagrams. This could be a flowchart, this could be a sequence diagram, a tree diagram, any kind of a visual which clearly explains the relationship among the variables. Whereas verbal and graphical models are very simple to start off with, and they're really handy to give you a overall picture of what you are trying to solve. Often, a limitation of these models is these are not adequate in incorporating or addressing the complexity that exists in the real life. So that is where mathematical models really come in handy. In a mathematical model, the exact verbal or graphical models are now transformed into a mathematical form, mostly through expressing these in the form of functions. So, in the same example that we have been discussing till now, let us assume y is a function of x, where you can imagine y to be the expenditure or the spend, and x is the income. Now, in its very basic form, mostly we come across linear relationships to start off with because that's very basic. And the function of a line is given by this equation y equal to mx plus c, where m is the slope and c is a constant. One drawback of, or probably one of the limitations of a mathematical model is that a mathematical model, although it expresses, things or a business situation in mathematical terms, it often does not, adequately capture the real world scenario because most of the mathematical forms are exact in nature. And the relationships that we discuss about in mathematical models are deterministic in nature. So there's really not much room for, errors or, there's not much room for addressing that, if the results from your model deviates from reality, you really do not have a lot of handy tools to capture that through a mathematical model. This is where statistical model really comes into the picture as a savior. And the significant difference between a mathematical model or a statistical and a statistical model lies in the fact that the later, which is a statistical model, incorporates this extra term, which is U. And this U stands for uncertainty. In any real world situation, uncertainty has a huge role to play. So, no matter how accurate your mathematical equation is or how accurately you try to formulate a certain problem, there is always a room for your results not to match what exactly is in actual, and this is what gets incorporated in a statistical model. So you can imagine that you are trying to let's take this same example where we are trying to understand what all factors exist which influence expenditure or spend of an individual. So in this case, y is our expenditure and x is our income. But income is just one of those variables which determines what is the amount of expenditure that an individual would incur. Apart from income, there could be multiple more other factors, right? It could be, his risk attitude. It could be what is the wealth he has inherited. What are his, liabilities. Other things, a lot of other things, right? So, in a statistical model, the term U is like an absorber term which kind of incorporates the effects of many such variables which you might not be able to track properly, or you might not have been able to find data for. For example, if you do not have a quantitative data for the risk appetite of an individual in determining how much he would spend. This kind of an effect would go in the error term or the uncertainty, which we generally know as. So any omitted variables, or even if you have certain variables that you have captured, but there's a chance that there could have been a measurement error in the variables that you are tracking. Even the effect of that gets absorbed in this error term. Additionally, also this is very common, and great part of research exists in this field of consumer behavior, where a lot of consumers, they do not act rationally. Now, what exactly we mean by rationally is that if you were given an extra dollar, to spend on a particular day, ideally the common, guess is that you would spend that dollar on buying something, or you might, invest it somewhere. But often than not, most of these consumer behaviors are quite random, and this is the inherent randomness of human behavior, which also gets captured through this uncertainty. And this is what helps us quantify, by how much margin, or by how much would the results of our model actually deviate from what is in actual. And we kind of try to arrive at a scientific way of coming up with a metric which kind of measures this deviation. And once we know the deviation, we kind of have more confidence in the model insights or the results that gets generated, because now we are not talking about one individual value, and we are not always talking about reaching one particular goal through a model. But what we are essentially trying to do is we are trying to build a model in such a way that you know the results are as close as possible to the real situation. So there are many further ways of constructing models, and there's a lot of theory behind that. But the crux of the matter here is that your model can be very simple to start off with, but to represent a real life scenario, the model needs to be adequately represented through the right specification, where you try to capture the right variables or factors for your model, and you should have the right amount of data. And there's a lot of considerations, assumptions, and limitations of your model that you need to take care of. Overall, the purpose of a model is to measure something, to measure a goal or an objective, and it absolutely helps in the decision process of any business or community. And this also is, in a way, a model helps also to validate the theory, and provide a lot of scientific evidence and explanation for the theory in the back end. One important concept also that is found in data science, typical data science projects, is that of conditional probability. And this is one important thing. If you have not gone through the lecture on probability, we would suggest you to go through that to have a deeper understanding on this subject. But what separates probability and conditional probability is the word conditional. So, for example, if we say that, if we just ask you that, what is the probability that it would rain on a particular day? If you have no prior information at all, your guess could be pretty random, and that's clearly not the objective of somebody who is trying to predict or forecast a particular event. What conditional probability helps us with is, if we know that a certain event has occurred in the past, does that help us improve our estimate about the probability of the same event occurring again in the future? So this kind of prior information about an event helps us determine you know the, the real probability, or helps us get closer to the actual probability that a certain event would occur in reality. And in this field also, uh, a common question that props up is that to represent a real life situation, how do we have, do we have all the information to represent a real life scenario? If we do not have that, how do we build a statistical model on some data and, we generalize that to the whole entire population? So there's this very interesting concept about sampling and population, and this brings us to, a more interesting and relevant topic, which is that of estimation and inference, where the whole idea here is that even if we do not have all the data or all of the information, we can still build a statistical model, and we can still have a scientific way of representing a real world scenario through a sample of the data. And there's a lot of theory, a lot of maths and statistics behind all of these tools and techniques that we deal with. And what we arrive at from these techniques is that even if we have a small data, we have certain checks in place to ensure that the sample that we have from the entire population is a good representation of the entire population, even because getting data about for the entire population is not feasible. There's a cost constraint, there's a time limitation, and often the set might be infinite, and it might not be really feasible to conduct a study which gathers data for a population. There's a storage issue, there's a lot of things, and often that's not really required, because if we ensure that the data that we have collected in the sample adequately represents the population, the trends, the proportions, uh, it kind of gives us a way to adequately represent the population and draw insights from there. And this entire concept of sampling and population, is very critical for us to uh, come up with reliable estimates from statistical models. And this helps a lot of practitioners in this field to draw inferences which can be now generalized for you know, for a real life situation. There are many such tools, and one important concept here is that of statistical significance and hypothesis. So in this case, for example, if you're given a study where you want to understand whether smoking really causes cancer or not, we need to understand that, to come to a conclusion in a scientific way about this, we need information and we need data. So assuming that we have data about different individuals who are smokers and who are not smokers and who have been affected by a disease, like cancer, and who have not been affected, if we have such information, we start off with a very basic hypothesis, which is, you can think of like a gut feeling, that smoking does not cause cancer, or smoking causes cancer, however it might be, depending on the situation. In this case, most likely it is that people would start off with a hypothesis which says that smoking uh, causes cancer, right? But the the null hypothesis is what we start off with, often tries to describe a situation where we try to see that we try to say that this is a no effect or a no impact situation. So even in marketing, for example, if you are trying to promote a brand and you have spent a lot of dollars in advertisement, the null hypothesis states that the advertisement spend, the advertising spend that one individual has made does not really affect sales. So that is the null hypothesis. And there's an entire test that goes on, which tests that this hypothesis is false, or this hypothesis cannot be accepted. So what we are aiming at is that if there has been an advertising spend, it should boost sales. So these kind of tests helps us to come up with numbers and estimates and attach a significance to that. from where we can say that we are 99% sure, or we are 90% sure that the advertising spend has boosted sales. There's a error margin also that takes into we need to take into consideration, and there are a lot of other tools and techniques which helps us assess how good the model is, how to understand if the model is robust enough, so that if tomorrow the data changes, the model still holds strong and good as today. So, hope this session was useful and gave you some kind of an overview about the topic and the idea why data science practitioners are, building models which a lot of people find very useful to use to solve complex business challenges. If there are any suggestions, if you have any inputs, I would love to hear your thoughts around the same. And it would be a good idea to subscribe to this channel, because we would be coming up with newer and relevant updates. So, hit that bell icon for the notifications, subscribe the channel to stay updated, and that's it. Wish you happy learning. Stay tuned. Thank you.